You can start, Ms. Noor.
Okay, so today, can you? Okay, so on behalf of Roshanida Rahman, so I will present today on the topic of mycelium bioform fabrication by waste paper. So thank you for the chairperson and the organizer. Okay, next. So, right, next slide. So here are the background of the study. So as for the background of this study, bioform is a biodegradable and eco-friendly materials, but renewable in the same time. On the other hand, bioform has a potential to replace the non-degradable EPS, which is extended polystyrene or styrofoam. So bioform is more sustainable compared to the styrofoam, as the bioform is made up of fungal mycelium and renewable lignocellulosic materials. So therefore, bioform, which is using a bio-based materials, which refer to the growth of substance from its components that renewable and sustainable, that can reduce pollution and solid waste issue, and accomplishing sustainability and save the environment. Next. So there are two main components of bioform, which are fungus and its substrate, and mostly lignocellulosic materials. So mycelium is an innate binding former for producing a bioform that have a fast-growing chitins, hyphae vegetative part of fungus. And in a simple way to say that mycelium will become a natural glue to gum the substrate. So here are, so beside the two important components that has been explained earlier, so the end product of bioform produced mostly affected by the environment condition, which are temperature, pH, light intensity, and also moisture content. So according to the literature review, so there are three types of fungus that will be investigated in this study, and here are the range of the condition that have been found in the literature as the basis range for this study. So why waste paper? So waste paper has been chosen for this study compared to other common lignocellulosic materials. So waste paper also an abundant and mostly end up at the landfill. So in the same time, waste paper also contains a lignocellulosic material, which are lignin, cellulose, lignin, and hemicellulose, and we can further explore it as a potential of recycling waste paper. Next. So, for the scope of study, there are three types of fungus that we use, which are Pleurotus ostratus, Volvaria volvaceae, and Schizophyllum commune. So these are all the edible fungus and also safe. And besides, the growth factors studied are temperature, spawn weight, and also moisture content. And lastly, the production of the bioform that had been produced will be characterized. Okay, here are the methodology. So in methodology, first is we begin with the inoculations of the fungus on PDA agar plate, and then we incubate at a standard procedure for 7 days to form a mycelium. So the waste paper will be prepared by cutting and soaking the the waste paper, and then we soak in water for 1 hour, and then we chop the waste paper and we and blend and place it in an autoclave to make it sterilized before we can use it for the for culture the mycelium after that. Next. Alright, so here are the first step, which are we screening the three types of fungus. So the three types of fungus will be cultured for 7 days, and the area of myceliums will be recorded and compared. Next, so only one of the fungus. So after we screening the types of fungus, and the best fungus will be chosen to optimize to the highest growth of area. So the best bioform produced was investigate from the state different temperature, spawn weight, and also moisture content, which highly affected the structure of the bioform. So the bioform will be dry in the oven at 104 degrees for 24 hours. Next. So here are the characterizations of the mycelium. So we will characterize the density of the mycelium bioform, the compression test, the scanning electron microsystem to determine the morphological of the bioform, and also FTIR to determine the functional group in bioform. So next, so here are the results. So for preliminary screening of mycelium was conducted at a room temperature for 7 days. So the mycelium growth of PO, P ostratus, and S commune on waste paper were determined with the area of 0.76 cm square and 0.35 cm square respectively, while no mycelium growth was detected when using vivo assay. Hence, PO was selected as the most suitable fungus growth on waste paper compared to other fungus. So next. So these are the following figure that I just want to show the growth of PO at different factors studied up to 10 days after the drying process. So this figure shows the appearance of the bioform at a different temperature, and we can see that at temperature of 40 after re-drying for 24 hours, there are no mycelium detected on top of the substrates, which means that at the temperature of 40, PO cannot grow further and after drying for 24 hours. Next. So this figure shows the appearance of a bioform from PO at a different spawn weight. So we can see a difference, a different appearance of the mycelium bioform at a different spawn weight, which is 5, 10, 20, 30, and 40. And we can see at 40% of spawn weight after drying for 24 hours shows a fully colonized of mycelium. Next. So for this figure, it also shows the appearance of bioform from PO at different moisture content. So after drying for 24 hours, we can see that a moisture content over 75% has produced a shrinkage of bioforms, which means that high moisture content could shrink the bioform. Here are the effect of the moisture content of a 60%. So a high concentration of mycelium will be observed on the top of substrate after 10 days. And the mycelium grow well on top of the substrate because of the gradient in oxygen concentration on top is more than the bottom when the air enters the lid of the containers at the top. So for the 75% of effect of moisture content, we can see that there is no colonizations of mycelium that can clearly observe at the bottom and the side of the biofilm with 70% of the moisture content. Next. So this one is an effect of moisture content, shows a different area with a different moisture content, where the moisture content of 60% shows a biggest area, which is less shrinkage than moisture content at 70%. Next. So here are the effect of different temperature on physical properties of biofilm. As we can see, that density is one of the factors that affect the physical material properties. So low weight and a low density of biofilm is a favorable properties where we consider in the packaging field. So the PO growth they place at 30%, 30 degree has the highest density of 0.334 gram per cm cube, while 40 degree has the lowest density, which is 0.242. However, the temperature above 30 degree and below 25 degree, the growth of the myceliums were inhibited. So besides, the highest optimal compressive force of the biofilm at deformation 50% was determined at 2.343 MPa when the PO was incubated at 30 degrees Celsius. So the mycelium was fully colonized onto the waste paper when it was incubated at temperature 30 degree. So more mycelium grows on the substrate, so the higher compressive force can withstand by the biofilm. So next factor study for PO growth on waste paper was spawn weight. So from the figure, it shows that the biofilm with 40% inoculum weight had more mycelium colonized on the waste paper after 10 days compared to other inoculum weight. So for the biofilm with spawn weight 40%, it had the highest compressive force, which is 1.788 MPa at 50% deformations. So this is due to the mycelium that is fully colonized on the waste paper and that provide support to the biofilm. Next is the different moisture content. So for the moisture content study, so in general observation, most of the mycelium only grow on the top of the waste paper when the moisture content was higher than 65%. So this is because mycelium hardly grow in a high moisture content substrate. So the biofilm with 60% moisture content can withstand the highest compressive force, which is 1.221 MPa, and the lowest compressive strength that withstand by biofilm was the biofilm with 70% of moisture content. So this is because less growth of 70% of moisture content of substrate, therefore mycelium has not sufficient support strength to the biofilm. Okay. So here are the morphology of the biofilm. So it shows an internal structure of mycelium in biofilm that we observe using scanning electron microscopy analysis. So it shows that the morphology of 30 degree incubated biofilm and the mycelium spread widely on the waste paper. So the FTIR result also indicate that the mycelium biofilm have a significant absorption on those scattered bands. So here are the broad absorption peak that was indicate presence of the OH group and show a typical carbohydrate pattern in FTIR analysis. So a summary of the bands with assignment are listed in this table, and it shows that mycelium bioform mainly consists of the polysaccharide, protein, and also lipid. So for the conclusion, this project is actually a preliminary study that varying three types of fungus growth on the waste paper as a substrate for the bioform production. And from this preliminary study, PO, which is Pleurotus austratus, resulted the highest colonized area on the waste paper compared to others two types of fungus and has a potential for bioform production. Besides, the result demonstrated the visual appearance, density, and also physical properties of bioform that influenced by varying its temperature, spawn weight, and also moisture content. So based on the compressive strength, 30% incubated bioform resulted the optimum compressive strength, and also morphology of the mycelium showed that the colonizations of the mycelium on the waste paper demonstrated a root network on waste paper, while chemical characteristic of bioform was tested and indicated mostly polysaccharide they contained in the bioform. So waste paper has a potential in the fabrication of biodegradable bioform when it colonized with suitable fungus and incubated at the optimum environment conditions. Thank you.